We have if x plus 2 and x minus 1 are factors of the polynomial 6x raised to the power 4 plus 2m raised to the power 3 minus 13x squared plus nx plus 14. If x plus 2 and x minus 1 are factors of the polynomial 6x raised to the power 4 plus m raised to the power 3 minus 13x squared plus nx plus 14, we have to find the values of m and n, values of m and n, and reminder when f of x is divided by x plus 1. The reminder when f of x is divided by x plus 1. The question says that if x plus 2 and x minus 1 are factors of the polynomial 6x raised to the power 4 plus mx raised to the power 3 minus 13x squared plus nx plus 14. Find the values of m and n. Reminder when f of x is divided by x plus 1. Let's look at the question. We have this polynomial 6x raised to the power 4 plus mx raised to the power 3 minus 13x squared plus nx plus 14 plus nx plus 14. So let's check remainder theorem. From remainder theorem, let's check remainder theorem. Now remainder theorem states that when the polynomial p of x is divided by x minus alpha, the remainder is p of alpha. The remainder is p of alpha. So that when the polynomial p of x is divided by x minus alpha, the remainder is p of alpha. P of alpha. Let's look at a sample that justifies this. This one says that if p of x is, if the polynomial 3x squared minus 2x minus 1 is divided by x minus 1, if the polynomial 3x squared minus 2x minus 1 is divided by x minus 1, we have to find the remainder. What we need to do is to make this x minus 1 equals to 0. And if x minus 1 equals to 0, I can obtain the value of x to be equals to 1. And if the value of x equals to 1, I can substitute it back into the polynomial to obtain the remainder. So if I put x equals to 1 into the polynomial 3x squared minus 2x minus 1, what am I going to have? So I'm going to have p of 1 equals to the remainder. P of 1 equals to the remainder, which is going to be 3 into 1 raised to the power 2 minus 2 into 1 minus 1. And this is going to give me 3 minus 2 minus 1. And that is giving me 3 minus 3. And the remainder equals to 0. Now, what does this implies? If the remainder equals to 0, implies that this polynomial x minus 1 is a factor of the polynomial 3x squared minus 2x minus 1. Then 3x minus 1 is a factor of 3x squared minus 2x minus 1. There's another method of obtaining the remainder, which is a long division, using long division approach. So we are not using long division, so we are making use of a remainder theorem. And that says that if this is this, that when the polynomial p of x is divided by x minus alpha, then the remainder is the p of alpha, and that is p of x equals to the divisor, where x minus 1 alpha is my divisor and k of x is the quotient, plus the remainder. So let's go back to our question and see what we have. We have 6x raised to the power 4 plus mx raised to the power 3 minus 13x squared plus nx plus 14 as to factor x plus 2, x minus 1. That implies that if I divide them 6x raised to the power 4 plus mx raised to the power 3 minus 13x squared plus nx plus 14 by x plus 2 into x minus 1, is going to give me 0. So let's go back to the question and solve. Now we've seen what the remainder theorem says. So if x plus 2 is a factor, then x plus 2 equals to 0 will give me x minus 2. So if I substitute x minus 2 into the polynomial, into this polynomial, I'm going to have a good result, and that result is the remainder. But we don't know the value of m, and we don't know the value of n. It means that our answer will be in terms of m and n. Our remainder will be in terms of m and n. So if x plus 2 is a factor of f of x, then the remainder equals to 0. That is substituting minus 2 into the polynomial. And if we do that, we are going to have 6 into minus 2 raised to the power 4 plus m into minus 2 raised to the power 3 minus 13 into minus 2 raised to the power 2 plus n into minus 2 plus 14. And that equals to 0, since x plus 2 is a factor of the polynomial. So let's simplify further. Minus 2 times minus 2 raised to the power 4 will give me 16. Minus 2 raised to the power 3 will give me minus 8. And minus 2 raised to the power 2 will give me 2. And it will be minus 2. So we are going to have a 6 times 16 plus m times minus 8 minus 13 times 4, then minus 2n plus 4, minus 2n plus 4, minus 2n plus 4. So if we simplify further, we have 6 times 16 will give me 96. 6 times 16 will give me 96. Then plus m times minus 8 will give me minus 8m. Minus 13 times 4 will give me minus 52. And minus 2n plus 14 equals to 0. So I'm going to have 96 minus 8m minus 52 minus 2n plus 14. So if we collect like terms, we are going to have 96 plus 14 minus 52 minus 8m minus 2n equals to 0. We are still using that polynomial, equals to 0. So 96 plus 14 will give me 110 minus 52 minus 8m minus 2n equals to 0. I'm going to have 110. 96 plus 14 will give me 110 minus 52 minus 8m minus 2n equals to 0. 110 minus 52 will give me 58. 58 minus 8m minus 2n equals to 0. So if I make 8 minus 8m minus 2m subject of the formula, if I make minus 8m minus 2n subject of the formula, it means I'm going to have 8m plus 2n equals to 58. 8m plus 2n equals to 58. So I can call this equation 1. So now let's pick the next factors of the polynomial, of this polynomial. Let's pick the next factor of the polynomial. So the next factor of this polynomial is x minus 1. Now if x minus 1 equals 0, I'm going to have x equals to 1. So it's a factor of the f of x, such that x minus 1 is equals to x minus into plus 1. And that gives me f of 1 equals to 6 into 1 raised to the power 4 plus 1 plus m into 1 raised to the power 3 minus 13 into 1 raised to the power 2 plus n into 1 plus 14 equals to 0. And 1 raised to the power 4 is 1, 1 raised to the power 3 is 1, 1 raised to the power 2 is 1 and 1. So we are going to have 6 plus m minus 13 plus n plus 14. 6 plus m minus 13 plus n plus 14 equals 0. So if I correct like times, I'm going to have 6 plus 14 minus 13 plus m plus n equals 0. And that gives me 20 minus 13. 20 minus 13 plus m plus n equals to 0. So 20 minus 13 plus m plus n equals 0. So this will be 7 plus n, making m plus n subject. If I make m plus n the subject, I'm going to have m plus n minus 7. M plus n equals to minus 7. M plus n equals to minus 7. So I call that equation 2. So the two factors has given me terms in terms of m and n. The first one was 8 plus n. 8m plus 2n equals to 58. And now equation 2 is giving me m plus n equals to minus 7. M plus n equals to minus 7. So let's solve equation 1 and equation 2 simultaneously. Solve equation 1 and 2 simultaneously. We have then equation 1 to be 8m plus 2n equals to 58. And we have equation 2 to be m plus n equals to minus 7. 8m plus 2n equals to 58. And m plus n equals to minus 7. So, using either substitution method or initial method, matrices, or any method that is convenient, we are going to make use of substitution method. So, from equation 2, I'll make m the subject of the formula. From equation 2, make m subject of the formula. Making m subject of the formula, I'm having m plus n equals to minus 7. Then m is going to be minus 7 minus n. Minus 7 minus n. So my m is minus 7 minus n. So let's call that equation 3. Equation 3. So if this equation 3 is substituted into equation 1, if m equals to minus 7 minus n is substituted into equation 1. So if you substitute that, I'm going to have 8m plus 2n equals to 58 from equation 1. Then substituting minus 7 minus n for m in the equation 1. I'm going to have 8 into minus 7 minus n close bracket plus 2n equals to 58. I'm going to have 8 into minus 7 minus n close bracket plus 2n equals to 58. So if we open this bracket, 8 times minus 7 give me minus 56, and 8 times minus 18 minus 8n, 8 times minus n will give me minus 18n, and then plus 2n equals to 58. So 8 times minus 7 is minus 56, 8 times minus n is minus 8n, plus 2n equals to 58. Now, let's collect like terms. So I'm going to have minus 8n plus 2n equals to 58 plus 56. Taking 56 to the other side. So plus 56. So this is going to be 50 plus 56. So I'm going to have minus 8n plus 2n equals to 58 plus 56. 58 plus 56. So n is common. N is common. If I factor out from minus 8n plus 2n, I'm going to have minus 8 plus 2. Minus 8 plus 2 into n equals to 114. 58 plus 56 is 114. So I'm going to have minus 6n equals to 114. Minus 6n equals to 114. Minus 6n equals to 114. And that will give me minus 6n equals to 114. So I need to divide both sides by minuses in order to obtain my n. To obtain the n, minus 6 divided both sides by minus 6. So I'll divide minus 6n divided by 6, and then 114 divided by minus 6. So if I do that, I'm going to have divide both sides by minus 6. If I divide both sides by minus 6, I will have minus cancel minus, then 6 to give me 1n. So I'm having n left. So n equals to 114 divided by 6, and that is going to give me minus 19. N is equals to minus 19. So if n is minus 19, I'm substituting the value of n equals to minus 19 into equation 3. N equals to minus 19. So I'm substituting n equals to minus 19 into equation 3. So if I substitute n equals to minus 19 into equation 3, and equation 3 is m equals to minus 7 minus n. Minus 7 minus n. So if I put minus 19 for n, I'm going to have m equals to minus 7 minus 19. Minus 19. And that gives us minus 7 plus 19. So that m equals to 12. M equals to 12. So m is 12 and n equals to minus 19. M is 12 and n equals to minus 19. So we're able to find the value of n and n. We find the value of m and n. m is 12, and n is 19. So we are going to have a new polynomial, which is normal mx and then nx. So we've obtained the value of m and we've obtained the value of n. So the new polynomial there is 6x raised to the power 4 plus 12x raised to the power 3 minus 13x squared plus minus 19x plus 14. Because I'm having my m to be 12 and n to be minus 19. Now let's check for the second question. The second question, we are looking for the remainder. If this polynomial 6x raised to the power 4 plus 12x raised to the power 3 minus 13x squared minus 19x plus 14 is divided by x plus 1 is divided by x plus 1. If I set x plus 1 equals to 0, if I set x plus 1 equals to 0, I'm going to have x equals to minus 1. And if x equals to minus 1, and we substitute the value of x minus 1 into the function, into the polynomial, I'm going to have r of equals to f of minus 1. My remainder will be r equals to f of minus 1. So my divisor here is s plus 1. Then I'm going to have my x to be minus 1. So that the remainder is going to be f of minus 1. So f of minus 1 is 6 into minus 1 raised to the power 4 plus 12 into minus 1 raised to the power 3 minus 13 into minus 1 raised to the power 2 minus 19 into minus 1 plus 14. So minus 1 raised to the power 4 is 1, minus 2 raised to the power 3 is minus 1, minus 1 raised to the power 2 is 1, and this is minus 1. So we have 6 plus 12 into minus 1 minus 13 into 1 minus 19 into minus 1, then plus 14. So we simplify and open this bracket. We have 6 plus 6 minus 12 minus 13 plus 19 plus 14. 6 minus 12 minus 13 plus 19 plus 14. So let's collect all positives value. So we have 6 minus 12 minus 13 plus 19 minus 14. So we're going to have 6 plus 19 plus 14 minus 12 minus 13. And that will give me 39 minus 25. 39 minus 25. So 39 minus 25 will give me a remainder of 14. So dividing the polynomial by x plus 1 will give me a remainder of 14. So the remainder when f of x is divided by x plus 1 is 14. The remainder when f of x is divided by x plus 1 is 14. All right, let's solve the next question. The square root, solve the equation square root of 4x minus 3 minus square root of 2x minus 5 equals to 2. Solve the equation. The square root of 4x minus 3 minus the square root of 2x minus 5 equals to 2. So we are giving them the square root of 4x minus 3 minus square root of 2x minus 5 equals to 2. So what do we need to do? We square both sides. You take the square root of both sides. Take the square of both sides. We are going to have open bracket the square root of 4x minus 3 minus square root of 2x minus 5 close bracket all square equals to 2 square. So let's take this for a. Let's say this is a. This one is a. Let's say this is a, and the whole of this is b. So we are going to have a minus b. We are going to have a minus b all square. We are going to have a minus b all square. a minus b all square. A minus b all square. Good. So we have a minus b all square. So we can expand it using expansion method. So if you open this bracket, if we try to expand this, we are going to have a minus b, a minus b, a minus b, a minus b, a minus b. So we have a minus b, and then we have a minus b, a minus b, a minus b, and that is what we have here. So that is what gives us the square root of 4x minus 3 minus 2x minus 5 into the square root of 4x minus 3 minus the square root of 2x minus 5 close bracket equals to 4. 2 raised to the power 2 equals to 4. Now, how do we expand this further? How do we expand that further? We are going to have we are having a minus b, a minus b, we are having a minus b in bracket, and we are having a minus b, a minus b, a minus b. So to open this bracket, we use 10 by 10. So a to multiply what is here and minus b to multiply what is here. So we have an a, we have an a into, we have a into, we have a into a into a into a minus b, a minus b, close bracket, and we have minus b into a minus b, a minus b, a minus b, a minus b. Now let's apply this to open this bracket. So these are a, these are b. So we are going to have square root 4x minus 3, square root 4x minus 3 into square root 4x minus 3 minus root 2x minus 5 close bracket, minus root 2x minus 5 open bracket, root 4x minus 3 minus root 2x minus 5, root 2x minus 5, root 2x minus 5. So going by this expansion, we know what our a is. So we have root 4x minus 3 open bracket, root 4x minus 3 minus root 2x minus 5. We are picking all of this, minus, the next one is this, minus root 2x minus 5 open bracket, root 4x minus 3 minus 2x minus 5 equals to 4, equals to 4. So let's operate it. So it means that this times this, this times this. So I'm going to have a times a, which is a square, and I'm going to have a times b, which is minus ab, and I'm going to have a minus b times a is going to give me minus ab as well. It's going to give me minus ab, and this time this will give me plus b square, plus b square, plus b square, plus b square, plus b square. Now let's apply this rule. So this time this will give me root 4x minus 3 all square. Then this will result into root 4x minus 3 into 2x minus 5 is together Then I'm going to have root 2x minus 5, then root 4x minus 3. Same thing. Then I'm going to have plus root 2x minus 5 all square. 2x minus 5 all square. 2x minus 5 all square. So we have the square root 4x minus 3 all square minus 2. Yes, 2 into root 4x minus 3, open bracket 2x minus 5 plus root 2x minus 5 all square. So let's look at this operation. Now from indices we know that this we cancel this, so the 2 has crossed out this, so we are left with 4x minus 3, and the same thing, the 2 here will cross out this root, so we are left with 2x minus 5. So we are going to have 4x minus 3 minus the square root minus 2 into square root of 4x minus 3, open bracket 2x minus 5 plus 2x minus 5 equals to 4. So if I collect like times, I'm going to have 4x plus 2x minus 5 minus 3. 4x plus 2x minus 5 minus 3. So we're going to have 4x plus 2x minus 3 minus 5. So let's simplify this further. I'm going to have 6x minus 8. 6x minus 8 minus 4. 6x minus 8 minus 4. And that'll give me 6x minus 8 minus 4. 6x minus 8 minus 4. So I cross this to the other side. To the right hand side, I'm going to have 6x minus 8 minus 4 equals to 2 into square root 4x minus 3. 2x minus 5, and that gives us 6x minus 12 equals to that. So if I divide all through by 2, because this 2 is like a scalar multiplication, so divide 2 by this all through, so I'm going to have 3x minus 6 equals to the square root of 4x minus 3 into 2x minus 5 into 2x minus 5. Now we square both sides again. So if we square both sides of the equation, we are going to have 3x minus 6 all square, then 4x minus 3 into 2x minus 5 all square. Square root of 4x minus 3 into 2x minus 5 all square. And we are going to have 3x minus 6 all square equals to 4x minus 3 2x minus 5 all square. So these two will knock this out, so the root will disappear. So I'm going to level with 3x minus 6 into 3x minus 6, so equals to 4x minus 3, open bracket 2x minus 5. So let's open the bracket as usual. So we are going to have 3x into 3x minus 6 into 3x minus 6, 4x into 2x minus 5 minus 3 into 2x minus 5. So 3 times 3 is 9x squared. Go to have 9x squared is 9x squared. 3x times minus 6 going to give us minus 18x. Minus 6 times this is going to give us minus 18x. Minus 6 times minus 6 going to have 36 equals to 4x times 2x. So we're going to have 8x squared. 4x times minus 8 minus 5, we're going to have minus 20x. Minus 3 times 2x, we're going to have minus 6x. Then minus times minus is going to give us plus 15x. Minus 3 times minus 5 is going to give us plus 15. So we have 9x squared minus 18x plus 36 equals to 8x squared minus 20x minus 6x plus 15. So if we call it like time, we have 9x squared minus 8x squared minus 18x that gives us minus 36x, then plus 20 minus 20x minus 6x give us minus 20x. So to the other side, that will give us plus 20x plus 36 minus 15 equals 0. We are trying to make everything to be equals to 0. So if we call this out, so 9x squared minus 8x squared will give us x squared, give us an x squared minus 36x plus 26x, that is 10x, plus 36 minus 15, that will give us plus 21 equals 0. Now, solving using factorization method, we have a quadratic equation which is x squared minus 10x plus 21. So we want to solve this using a factorization method. So if I multiply this x squared by 21, so I'm going to have 21x squared. 21x squared. I need a factor of 21x squared. So what multiply to give me 21x squared? So I'm having 3 and 7. So 3x and 7x. 3x and 7x will give me 21. 3x times 7x will give me 21x squared. Now let's add. Plus 3 plus 7 is 10x, but this here is minus, so we want something that will give us minus. So if we put minus here and minus here, so minus 3x times minus 7x is going to give me plus 21x squared, and then minus 3 minus 3x minus 7x will give me minus 10x. So I'm going to use, instead of me writing minus 10x, I'll be writing minus 7x and minus 3x. So here I'm going to have x squared minus 7x minus 3x plus 21 equals to 0. So x is common to this and this. Minus 3 is common to this and this. So if I factor that, I'm going to have x into x minus 7 minus 3 into x minus 7 equals 0. S into x minus 7 minus 3 into x minus 7 all equals to 0. Now, you can see it's either x minus 3 or x minus 7 equals 0. So, x minus 3, x minus 7 equals 0. Now, if I open this bracket, I'm coming back to x squared minus 10x plus 21 equals 0. That is the implication. So, x minus 3 equals 0 or x minus 7 equals 0. If I equate x minus 3 equals 0, I'm going to have x equals to 3. And if I equate minus 7, x minus 7 equals to 0, I'm going to have x equals to 7. So my value are x equals to 3 or x is equals to 7.